Hello everyone, hope you are all good. Welcome to today's class on matter in our surroundings. Yesterday we discussed about the matter and the particulate nature of matter. We also discussed about an experiment to prove that the matter is made up of particles. The experiment was we had taken some water in a beaker and added salt or sugar into it. There was no change in the level of water. The salt disappeared, and we learned that the particles of salt occupied the empty space available between the water molecules or water particles. So this experiment proved that there is empty space between the particles. There is empty space between particles. And this is one of the properties of matter. Today we will be discussing about a few more experiments and we will come to know the other properties of matter as well. We will discuss an experiment now. What we do is we'll take 100 ml of water in a beaker and we add a small crystal of potassium permanganate. All of you know potassium permanganate is KMnO4. This will dissolve completely in water and it will give a purple color to the solution. Now what we do is we take just 10 ml out of the solution, put it into 90 ml of water. 90 ml water plus 10 ml of solution which you have taken from the first beaker. So the total becomes 100 ml. Solution is still purple but not as intense as this solution. We repeat the experiment. From here again we take 10 ml solution, put it into 90 ml of water, 90 ml of water, 10 ml from this solution. Total becomes 100 ml. You can see the solution is still purple, but it is lighter compared to this solution. Repeat the experiment, take another 10 ml from this solution and we put it into 90 ml water, 10 ml solution makes it 100 ml. You can see the solution is still purple, but it is much lighter compared to the original solution. Now, what this experiment shows is that just a few crystals of potassium permanganate can color a large volume of water. So, the experiment clearly concludes that there must be millions of tiny particles of potassium permanganate in just one crystal of potassium permanganate. So, as we dilute it further and further, the number of particles keep decreasing So this experiment clearly shows that the particles are very, very small. Particles of matter are very, very small. So the experiment took to prove that particles of matter are very, very small. This is what we explained. Take 100 ml water, add a speck of potassium permanganate or a crystal of potassium permanganate, take 10 ml from here, dilute with 90 ml water, make it 100 ml. Further, you continue the reaction, continue the process, and ultimately you get a solution of potassium permanganate which is still purple in color. So thus we come to the second property of matter, the particles of matter, that particles of matter are extremely small, very, very small particles. Let us discuss another experiment. Here what we do is, we just put a drop of ink. You can see here a drop of blue ink is put into a glass of water. This is water taken in a tumbler or a glass, and a drop of ink is put into it. We will not disturb this solution any further. We'll just keep it undisturbed. Now wait for some time. What we will see is slowly the ink drop spreads into the solution. You can see it is started spreading. It is spread even more here. It has spread even more here. Ultimately, it is evenly spread into the solution. It is evenly spread into the solution. Now the question is, why does this happen? We did not disturb the solution at all. You know, ink is a matter. This must be made up of particles. So if these particles have to evenly spread out in water, these particles must be moving around. Without the particles moving, it cannot spread into the water. So you can see here, this was how the drop of ink was initially. We put it into water, it spread out because these particles are moving in all possible directions. It further moves around. The same thing is explained here again. A drop of dye here, it starts spreading. Ultimately it is spread into the entire volume of water. So this becomes evenly spread out. What does this prove? This proves that the particles of matter are moving continuously. They are in continuous movement, continuously moving. And this process is also called diffusion. So how would we define diffusion? It is the intermixing of the particles of two different matter, and they intermix each other because of the movement of the particles. Now we will see what will be the effect of temperature on this experiment. Effect of temperature on this experiment. Will the particles be moving more faster, or will there be no change, or will they be moving less faster? Obviously, the answer is very obvious. It will be more faster. And how will we explain it? When we heat or when we supply heat, increase the temperature, the particles get more kinetic energy. Kinetic energy means energy possessed by the particles which are in motion. When the kinetic energy increases, they move more faster. And this process will be much more faster. So we learned the third property of the particles of matter. The particles are under continuous motion. We also defined diffusion. It is the intermixing of particles of two different types of matter on their own. We don't have to do anything. They move on their own. Is called diffusion. So how do we define diffusion? Diffusion is the intermixing of particles of two different matter. Intermixing of particles of two different matter on their own, which means they move on their own. We do not have to do anything. They will move on their own. So we've learned the third property of particles of matter. They are under constant motion. Let us see the next property. I have some chalk pieces and some iron nails. What if I try to break them? Answer is very obvious. You have the answer. Chalk can be easily broken. Whereas it is not so easy to break iron nails. Not so easy. Now, how would we define it? How would we explain it? It is possible to break chalk easily because the attractive force between the particles of chalk is comparatively very less. That means the particles are attracted to each other. There is attractive force between the particles of any matter. The only difference is this attractive force is different in different matter. Attractive force is different. Chalk, the attractive force is very less, so we are able to break them very easily. Iron, the attractive force is very strong, so we are not able to break them so very easily. So thus comes the fourth property of matter, the particles are attracted to each other, or there is attractive force between the particles of matter. There is attractive force between the particles of the matter. So we explained all the properties of matter. Let us quickly revise. The particles of matter are very, very small. Which experiment proved it? The particles of matter are very, very small. The experiment which we did with potassium permanganate. Yes. This proves that they are extremely small, because even after diluting many number of times, the solution still is colored. The next property is particles of matter have space between them. Which experiment proved this? The experiment which we discussed yesterday. You put a cube of sugar into water or salt into water. The salt disappears, no change in the level of water, because the salt particles get into the empty space which are available between the particles of water. So this experiment proves that there is empty space between the particles of matter. Let us see the next property. The particles of matter are constantly moving. Which experiment proved this? The experiment where we put a drop of ink into water. Even if we did not stir it or disturb it, ultimately the particles of ink evenly distributed or evenly spread out in water. This proves that they are moving continuously or constantly. The last property, particles of matter attract each other. Which experiment proved this? The fact that chalk can be easily broken, whereas iron nail cannot be easily broken. This is because attractive force between the particles available in chalk is very, very weak, whereas attractive force between the particles in iron is very, very strong. So we are not able to break them so very easily. So all the four properties once again. The particles of matter are very, very small. The particles of matter have spaces between them. The particles of matter are constantly moving. And the last property is the particles of matter attract each other. So what are the things we've learned today? We learned about the properties of matter. We also learned about a property called diffusion. What exactly is diffusion? The intermixing of particles of matter on their own. These particles mix with the particles of water on their own without having to do anything by an external agency. It happens on its own. And this property is called diffusion. So that's all about today's class. I'll be giving the questions and answers below the video, and learn them. Bye. See you in the next class.